The cylinder head for the F3 675 and 800 Euro 4 has gone through some major revisions and technical updates for the Euro 4 homologation. The modifications of the cylinder head started out with modifications to the machining of the casting itself, with the incorporation of the harmonic damper laterally in the area of the cam drive chain in order to reduce external noise emission, as well as the incorporation of a mechanical cam chain tensioner. The mechanical cam chain tensioner keeps the cam chain tension constant over the entire driving cycle and degradation of the oil. So in the past, with a hydraulic cam chain tensioner that could change cam chain tension as a function of oil pressure, as a function of oil degradation, we now have the mechanical chain tensioner keeping that tension constant over all conditions of engine function. On the intake and the exhaust side, we have new valve guides. These valve guides are made out of sintered material. And the material itself has been heavily modified and developed for Euro 4 with two precise goals in mind. One is to resist the higher temperatures that are generated inside of a Euro 4 compliant engine. And number two is in order to increase the longevity and the durability of the engine, both on the intake and on the exhaust side. The primary goals of the transformation from Euro 3 to Euro 4 were to maintain the peak power and peak torque values of Euro 3, while at the same time meeting the emissions and sound requirements of Euro 4. In order to do that, we worked very heavily on the intake cam profile and exhaust cam phasing. The intake cam profile is completely new, and while reducing the maximum lift of about 0.3 of a millimeter of the intake valve, we increase the time area, or the time the intake valve is open, and the trapping efficiency to maintain air and fuel inside of the combustion chamber. In this way, we were able to optimize both swirl, tumble, and combustion efficiency to give us the power to meet the requirements, while at the same time reducing the velocities and the accelerations of the intake valve. Coupled to the intake and exhaust camshafts are our valve springs. For the F3 675, we have a single spring, both on intake and exhaust. This is a very particular spring, and that it has a beehive shape, or it's shaped rather oval. And this is to reduce the mass at the top part of the spring, so the mass that we're moving with the cam follower, the bucket, is lower, and therefore the loads on the cam system are lower. For the F3 800, which has a lower RPM limit at 13,800 compared to 15,000 RPM for the F3 675, we now have a dual spring setup. So on intake and exhaust valves, we have an external spring and an internal spring. These springs are used in order to reduce side loads from the springs. They can also reduce wear on the interface between the valve guide and the valve itself.